This is a GCSE AQA chemistry question. It's from the Trilogy 2019 paper and it is a higher tier question. Going to recommend you pause, try the question first and then we review. Here is part A, part B, part C, part D, and finally part E. So let's take a look at the review. In part A, what is the correct ionic equation for the reaction? Well, I'm actually going to build the ionic equation so we can see this. I've got my Mg, my 2HCl, MgCl2 and H2. When I make an ionic equation, or when I create or produce an ionic equation, I will break up anything that is aqueous and ionic. So in this case, I break up my HCl and my MgCl2. What I can then do is get rid of my spectators. I've got 2Cl minus on both sides, so let's get rid of them. And you can then see that we're left with Mg plus 2H plus goes to Mg2 plus H2. So we have our correct answer. On to part B. What happens in the reaction between magnesium and hydrochloric acid? So this is a transfer. It's the formation of ions. We've gone from Mg to Mg plus 2. As an example, we've gone from H plus to H2. So we've got loss and gain of electrons. It's ionic, so it's electron transfer. In terms of the graph, possibly you didn't do this one, but just talking through it, plotting the points on these, really, really important. You take the time to do it with care, because often, or sometimes, people can look at graphs, think they're very simple, race through, and actually not plot correctly. Once you've done that, the line of best fit, one smooth sweeping curve in this particular case. On to part D, describe the changes in the rate of this reaction. Well, we've got the graph here and we need to describe the entirety of this shape. So, the rate decreases as the reaction continues. We can see that because the gradient is getting shallower. It's getting less steep. But the rate at which it decreases over time. So it goes shallower, 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 and then eventually, the rate eventually reduces to 0, and the reaction stops. 3 marks to be had there. On to part E, to finish off this question, explain why the rate of this reaction changes, and give your answer in terms of collision theory. Well, you start off with entirely reacting particles, but the minute they react, we have less of them. So there are fewer reacting particles as the reaction progresses. If there are fewer reacting particles, that means there are less frequent collisions, less frequent successful collisions. So the reaction will stop when one of the reactants is used up. We call that the limiting reagent. That takes us to the end of this question.